continuing with our introductory chapter, we're heading into radicals and simplifying radicals, something that you definitely covered in Algebra 2 and possibly a little bit in Geometry and Algebra 1. But we're going to talk a little bit about the rules, how we simplify radicals. Radicals being roots. In Algebra 2, you covered more likely other roots, but we're going to stick with just square roots today and later worry about other roots. So when we're talking about square roots, what are we talking about? If I say square root of 64, why is the answer 8? Because this is the number times itself. Number times itself that equals 64. That equals, and it's not just 64, but what is under the square root. If you look at the list in front of you, all of these numbers happen to be perfect squares, and all these expressions show perfect squares. Just a caution, we obviously cannot take square root of a negative number. If I have square root of negative 49, and I said what number times itself equals negative 49, well, there is no number because a negative times a positive is the only way to get a negative number. So those numbers wouldn't be the same number. This is where we get into those imaginary numbers, which we'll cover later on in this semester. But if we have the square root of a positive number, it doesn't matter if the negative sign is out front, the negative sign just comes along and we answer the question as negative 7 because 7 is the square root of 49. If you look at the other options, all of these show perfect squares. Think to yourself, make sure you understand why each of these are perfect squares. If you don't, bring a question to class on Friday. Some useful properties, we're going to talk about simplifying square roots, not just identifying perfect squares, but some useful properties for simplifying square roots. You can actually break a square root into its factors and break a square root into its factors by multiplication. So for instance, we have 48 here, which we know is 6 times 8. We can actually rewrite this as, okay, what's inside the square root? 48 is 6 times 8, but then the property that becomes useful is that when we have those factors, we can actually write those as 2 separate square roots. So keep that in mind for simplifying radicals. And the other thing you want to keep in mind, so first thing is you can break apart into multiple square roots. And I'm going to put with multiplication. It's not, you can't use any operation you want. But we can break it apart into multiple square roots. And then also, this second example here is illustrating a property. If you have the square root of 2 times itself, or it might be easier to think of something that you know, square root of 4 times the square root of 4. Well, both of those are 2. 2 times 2, if we simplified that, the answer is 4. So what do you notice if you consider the square roots? Well, a root times itself is going to just give you that number inside the square root. So root 2 times root 2 is just going to give you 2. Those little pieces are going to help us actually simplify square roots. So we have an example here. We're going to use 48 again. I want to rewrite 48 as its factors, and I'm actually going to use that second property, keeping in mind square root of 2 times the square root of 2 is 2. I want to keep that information in mind. So what I'm going to do is actually write out the factors of 48. I have 2 and 24, and I'm just going a different route to show you don't have to use the same factors every time, but 2 and 12, 2 and 6, and 2 and 3. So if I was going to rewrite square root of 48, I could rewrite it as square root of 2. And remember, when we do our factor trees, we only use the ends of our branches. Square root of 2 times 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 the square root of 3. So there were my factors. 4 2's and a 3 multiplied would give you 48. I'm going to use this property we just talked about up at the top, and what I'm going to do is find square roots, matching square roots. Root 2 times root 2 is going to give me 2. I have another set of root 2 times root 2. That's going to give me another 2. And then notice the square root of 3. Well, it doesn't have a pair to match up with. It's just going to stay as square root of 3. What operation was I using between all of these? It was multiplication. So if I have identical square roots, I can multiply them and get that number inside the square root. So my final answer, 2 times 2 on the outside would give me 4. 3 would give me, square root of 3 on the inside of the root. You may have learned other methods. For instance, sometimes I teach you look for pairs, you break down your number into its factors and just look for pairs, and any pair can move outside the square root. Anything that doesn't have a pair, so the 3 stays inside the square root. You can think of it in multiple ways, but why it works this way to simplify radicals is because of what you just saw. Simplifying radicals can take multiple forms. I'd like you to try the square root of 72 on your own, but what about when we come to something like 54x to the third? What about when we come to something with a variable? It works very much the same way. We break that number down, 2 and 27, 9 and 3, 3 and 3. So the square root of 54 becomes square root of 2 times square root of 3 times square root of 3 times square root of 3. And if you think about the x to the third, what's x to the third really mean? Well, it means x times x times x. The exponent tells you how many times to repeat the base. So we really can just go ahead and keep going with our x's. Square root of x times square root of x times square root of x. What can we pair up? Well, we got a root 3 times a root 3. That will give me a 3. You got a root x times a root x. That would give me x times x. And then everything else doesn't have anything to pair up with. So we have square root of 2 times square root of 3 times square root of x. So much like we can break apart a square root into multiplication, we can use the multiplication to put everything back under one square root. So our final answer here would be 3x square root 2 times 3 is 6, and then times x. These rules only work with multiplication, so don't try and take them into addition or subtraction of radicals. I'm going to leave this last question for you to try based off of what you just saw with the variables. But I want to show you also that you can use the reverse kind of rule. Instead of breaking apart a square root with multiplication, you could just put everything under one square root. So 16 times 3 would be 18, x times x would be x squared, and then you could break the number apart. 18 is 2 times 3 times 3, x squared is x times x. So there's a group that's going to make 3. There's a group that's going to make x. And then root 2 didn't have a pair to go with. So key for simplifying radicals: for square roots, look for pairs. Radicals with fractions look harder than they actually are. The thing you want to make sure that you just remember is, what's the square root asking? It's saying what number times itself will give you, for instance, 1 over 49. I'm going to show you a shortcut, another rule. So we could take let's do 8 here. We could take a radical and we could break it into its pieces using multiplication, or the opposite. We could combine them. It can go either way, forwards or backwards. The same kind of rule applies for division. You can actually break a big square root of 1 over 49, a fraction, into 2 separate square roots. Make it into a much easier problem. So square root of 1 is 1, and square root of 49, is 7. So 1/7 would be your answer. So go ahead and try that one just to practice that same rule. Radicals with fractions work the same way. Radicals with fractions work the same way, but sometimes you might get a little bit more complicated. At times, it may be advantageous to break a fraction, like the examples we just saw, break a fraction into two separate square roots. On the other hand, it may be useful to put everything under one square root instead and simplify. My suggestion is always, if you have a fraction, look to simplify it first. So is there anything we can simplify? Absolutely. 72 and 8 can both be divided by 8. That leaves us with 9 in the numerator and 1 in the denominator. And if you remember your exponent rules we just had the quiz on, x to the third over x to the first, we're going to subtract our exponents. So this problem becomes a much easier problem, simplifying your fraction first. We have the square root of 9x squared on top, square root of 1 on bottom, which you don't really even need to care about. Square root of 1, 1. Square root of 9x squared, remembering your simplifying rules. That's square root of 3 times square root of 3 times square root of x times square root of x, because it's x squared. We have two x's. So each group, first group gives me 3, the second group gives me x. So simplifying can be much easier with the radicals if you simplify your fraction first. Use those radical rules for breaking apart multiplication, division, or combining them back together. Last problem I'm leaving for you to try. So you have 3 problems I believe I left you with to attempt. Make sure you come prepared with these on Friday. Thank you.